Okay. The stream has started. The sound looks good, and I will start. Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. We are today on an adventure to parse what Windows calls the symbol file and the type file, or well, you can call it a symbol table and a types table, which basically is just, a whole set of information useful for debugging, and is the information that Visual Studio and Windows debuggers use to show and to expose the information into the debugger interface, which we will take advantage of it, and we will try to see how can we do the same, extract those symbols and extract those types from the symbol tables. And yeah, that's our task. That's where we are aiming for, and we will find it. Okay, so please, if you would like to follow along, you are welcome to do it. Please, if you have any questions, ask them on Twitch, Twitter, or YouTube, and I'll be there to answer. Alright, with that said, I would like to continue and open the code. I have already opened it. So we can continue here. I think we didn't do pretty much yesterday for the code. Oh, but we found an interesting web page that it's this one, and we should not take for granted what this says, but at least for a starting point, it's good. It basically explains the symbol format and the symbol tables and the types tables that are inside a pt2, could be, or inside an object file, who knows. And we can extract it using using this kind of information. So let's see. Okay. Com, that means communal. Communal. External, communal, definitions, data, definitions, external. Okay, so probably, I mean, this object file, it's what serves as input to the symbol tables and all this stuff, yeah. Okay, because I mean, basically, if you think about it, I mean, all this information is inside there. Although this is more like raw, you know, in like more part. What you would like, I mean, well, a parser should do or something like that, you know, like a first parser. And it has pretty much a similar format, you know. The maximum size for the entire record is 1024 bytes. Okay. Well, I mean, I was just like, what was that? But it's not our main priority right now. We will look at that probably later. But let's come back to this. From the frame pointer. Okay. So you are talking about in the stack frame pointer, at a current stack frame, with not pushes into the stack frame after it. And yeah, if all that happens to be, yeah, this is the thing that you would assume. Okay, but I don't know why they mix all this stuff. I mean, I don't know why they talk about frame pointers when talking about symbols. Uh, uh, I don't know, but I got it. Okay. Okay. And, I mean, sometimes they say type index of the symbol, and that means that it's an index into the types table. And sometimes they say type of symbol, which I don't know if it's literally the type. So yeah, I mean, I think that's the kind of janky thing. So if you see, I mean, if you guys can see this, as I see it, is that, I mean, they, I mean, they are talking basically, I mean, correct me if I'm wrong, they are talking basically about the thing that we were looking at the IF32 of the way that the stack allocations were done by the processor. If there was a file allocation for modules outside the process space, or for modules where if it was for, and if it was new, if it was for the same code process space and this code segments that were inside the process, you know, and data segments, of course, and the stack segments. So I believe that's what they're talking about here. There's a near caller and a far caller equally. The return, there's a far caller, far returning, and a near returning. It all depends on how you see it, you know, because it can be the function that's expecting a return from there, or it can be the function that's expecting a call from it, you know. So yeah. So I mean, the only way that they could know that the data is on a specific register is because the matching instruction is gonna be specifically no, you know. It's gonna be something like move blah specific pointer onto RAX, for example, let's say, and that RAX is gonna be the register which would contain the data itself as the return data, you know. But if you remember, that was not the only way for specifying a return data, you know. It can be on the registers, which is like the most common way. It can be on data in memory, on the data segment, which this doesn't specify, and which this doesn't tell me, hey, you know, what's that data, where's the data, how is the data, you know. And yeah, I think it's not complete. I think we need the binary. We need to get the binary, man. Probably that's what this is telling me. I mean, it has useful stuff, but it doesn't have everything, you know, everything we want to see from it. We have to take the data ourselves. But I mean, this is this also the return value, or what is this? Because I mean, this has all this stuff, and then I don't know, I don't see this. It should, but it has the count of number of registers that's gonna return. Okay. I don't know, it's it's kind of weird, but length and symbol. The actual function parameters and the local non-static variables of functions. Let's see, yeah. Okay, so for 16, yeah, it's BP. We don't care too much right now for 16 because we're targeting 32 and 64. Although, yeah, I mean, there's a BP pointer. So I believe we have Milton here. Yes, we do. And yeah, so this is BP. It gets the frame pointer. Okay. The symbols are used for data that is not supported from my module. And this is important because the CB pack, whatever is that I think it's basically the thing that manages this code. I mean, the CB pack is gonna read this thing and it's gonna transform it and pass it onto the exec file, you know. Uh, 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 length prefix name of symbol. And can be compacted into the global symbol table. Hold me a second. Section 7. Okay, structures, enumeration, procedure. Okay, cool. The symbol, we have the executable format spec right there. Or RAM. Let's see, local store. Okay, so it's a little bit larger. It has a length, the symbol, the parent, the end, the next, the procedure length, the debug store, the debug end, the offset, the segment, the procedure type, the flags, and name. So I think that's pretty much it. Okay, so this has these two variables that basically tells like which is the stack frame for the variables in that scope. And the interesting thing is that it's not the same, you know. I mean, because what I was assuming is that this the well no, I mean it's not the same of course, but uh you know, in this stack, let me go here, you know, we have this stack pointer, you know, and whenever we call some instruction or some function, let's say, it's gonna have it's not, I mean, a function is really a pointer, you know, that's all it is. So if we have a pointer to that address, I believed that that pointer was the initial point for the stack frame, but they say that it's not, or probably that says that there's an offsetting byte from the start of the procedure pointer. No. Yeah, from the start for the procedure pointer to the point where the stack frame has been set up. So, yeah, I mean, so is the stack frame? I don't know if they say SP or BP. I don't know. Well, this is the stack frame. It should be BP, so that SP continues carrying and moving downwards. But we can take a look. Doesn't matter. Frame pointer omitted. Shall know what that means. That means like a inline function or something like that. Okay, so it works like as an optimization. So I mean, I thought it was like the, well, I mean, it's the kind of the default thing to happen, that you always, when you uh, call a function, it creates a frame pointer, you know. But it can we can opt out not to do it. And the way to do it is with these flags for the compiler, where it says, hey, I don't want you to create those instructions, I don't want to create a frame pointer. So that probably makes me think that they are not gonna use the call instruction, and they're gonna use some kind of jumping, yes, that this thing that they tell her, like, yeah, they would use some kind of set jump or allocation, or although I don't know, I mean, yeah, I mean, they can use jumps, and that's it, I guess, in an inline, the non-branch way, which probably it's good. It depends. Yeah, it depends on the size of the stack code, the size of the function code. If it's too long, inlining all that stuff will be like crazy. For the compile, well, it depends. And you also have to see that, I mean, the compiler probably, well, I think it's possible. Okay, I will see. I see. Oh my god, this is where bananas come. Okay. Yeah, I mean, we have the v table, and the v table is going to be, we can define it inside here with the thunk. So I mean, if you're going to making a virtual call, it's going to do a thunk instead of a function call. Am I correct? Okay, so okay. All right, so it has this nice. It calculated the length in bytes of the scope of this block. Okay. Well, I don't know if that's. I mean, yeah, it's useful, of course, but we have to see if that's correct. Okay, at all. Uh, the offset portion of the semantic procedure address. And this is for Pascal, that is another language. And what is code label? What is the code label? Of separation of the code label address. Second portion of the code label. Okay, whatever. P code, pseudocode, probably. Code padding for alignment, microfocus cover, reserved for specific non-code types, padding for data, comparison jump table. ES and BX. Okay, these are the 32 bits. Choose now something that we will probably need to parse. This something now goes for the 32 architectures. So you think about it, what this means is that symbols is they are gonna be duplicated, you know, because you think about it. Well, for example, a function. Let me go take a look. Let's see. We have this function call, you know, that's a static, and it's gonna have these parameters that set up pointers to user defined types, which are structs, and we know that for in this case, if we look at the symbol file table, we will find out that, for example, the buffer, it's a non-static symbol, which is a local variable, so it's going to enter it as a local variable symbol. I don't remember, it was the name, but something like that. And also it's going to be a stack symbol or a BP relative symbol in this case, because it's also a symbol that it's inside the stack. And so yeah, I mean that's the reason that we have like duplicates in the sense that it's gonna be the same symbol name, although they mean different stuff, you know, like, yeah, I mean different attributes for the same symbol, I guess, or the same name. So it's a symbol for BP relative, a symbol for non-static data, symbol for pre-initialized data. Probably, I don't know if they have that. Probably they don't have that. Symbols for arrays. I think they have arrays there. Yeah. So there's an array of symbols of the same type, and we have you know, many kinds of that stuff, you know. So our job is to basically graph the whole symbol set, you know. And if you want to do that, so you want to have like to graph the whole most all the symbols for the same name, and I don't know how we're gonna find those all together. Let's see. So if we have something that's BP relative and something that is register relative, what does register relative means? Oh, oh yeah, I remember. It was something like yeah, if a register was has a pointer inside, then we will have something like a register relative thing, you know, that we can offset from that. But the thing that we were looking at, from for example in the stack, where every time we use it was used for BP, but we can use any register at all, you know. I mean, actually, I don't know why they, well, you can do it, but I mean, basically BP relative is just the same as register relative, you know. It's a register relative, just they have another name for it, I guess. And since BP is more specific for stacks, they have different data encoded into there, but you can handle them basically the same way. Okay. This symbol specifies symbols are allocated value to register. Yeah. To a pointer inside a register value. Please, Mr. You don't define specifically what this is talking about. But hey, sometimes that's the way it goes. Okay, so let me, yeah, we have to go on the 32 to see what's going on here. We got local data. As you see, they are different. This one is different from the one we got on the 1616. The 1616 one what had I believe, oh no, it has the same things. Yeah, probably, I mean, they can change sometimes. Yeah, 1616, 1632. Local data, global data. Basically, it's the same, isn't it? We have this image has the same format as the local data. It is reserved to symbols in the public table emitted by the link into the symbol and type of image portion of the executable file. So there's a portion in the image that handles symbol and type of image portion. So we have something there that we can trace there. Public, but I mean, normally they don't put it there. So I think that's, I don't know what we find out there. Global data symbol is the same format. And this is the local procedure. This is a global procedure, the thunk star, the block star, the width star, code label, which doesn't have any definition. The change execution model, virtual function table path, register relative, local thread. Okay, and this has local thread storage in 1632. And if you can see, this is the segment. Now the yeah, and EVX, but it was yes. I don't remember. It was, let me see. Let me run this stuff so we can see. And I hate that they don't have these kept segments. Yeah, this is a segment, but this is not a pair of registers. This is a segment and a registers. Jesus Christ. Jesus Christ, why did they? Oh my goodness. Okay, local thread storage. So I think it's the same. Everything it's the same. The execution model it's basically the same. Have table, register relative, all this. Oh, and this is the local thread storage. the segment of thread local storage, thread local storage. I mean, both go to local thread storage, well, thread local storage, I think. But the only thing that they happens is that in the image file, one is gonna be compacted into the global symbol table, and the other is not. This is for MIPS. We don't care too much about MIPS. This is for CB pack. What CB? I mean, let me go. Let me find out about CB pack, because since it happens to be here. They don't say anything about CB pack. Oh my god. Oh my god. Okay, so this symbol is inserted into the global and static symbol tables. Okay, I'm starting to see we can add them to this procedure reference so we can find it more easily on the hash. With the hash, So let me see before going. Okay. We are getting into it. Let's follow along. Submit may appear in linkable modules. It provides text descriptions and types. Okay, blah blah. So the types have a different format than the symbol table, which is a little bit bizarre. Well, it's not. It's not bizarre that it's different, but it's bizarre this format. We have a leaf, and it's the index as described below, and you have the data specified to each leaf type. The first range is for the type records that are directly referenced in symbols. The second range is for types records that are not referenced by symbols, but instead are referenced by other type records. Okay. Leaf indices for type records that can be referenced from symbols are the following: a modifier, a pointer, an array, a class, a structure, a union, an enum, a procedure, a function, a pt2 shape, virtual table shape, a couple 0, a couple 1, a bit byte array, I guess, a label, a null, a node transfer, dimensional array, virtual function table path, the precompiler, the M precompiler, the OEM. Okay, that seems reasonable. Leaf indices for type records that can be referenced from other type records are the following: skip argument lists are okay. The argument list, default arguments list, a field list, derived bit field, method list, dim conlu, dim bar u, dim bar lu, ref symbol. Leaf indices for fields of complex lists are the following: a big class, a bb. Also, they are the same. Oh no, this is a b array, and this is a by class, a virtual by class. I don't know what b is. IVV class, enumerate, friend function. Yeah. There's an index, a member, a static member, a method, a nested type, a function table, virtual function table that is not the same. This is the path, and this is the table. A friend class, oh Jesus, and a one method, and a function, virtual function COF. Okay, common object file. Leaf leaf indices for numeric fields of symbols and type records are the following. Okay, so these are the numeric fields, which are like the ones we will expect from a normal, I mean, what we recognize as types, and it's well, among fundamental types and numeric types, there's a numeric, a car, a shore, are you sure, a long, are you long, a real 32, a real 64, real 80, real 128. I don't know what, well, that's not from the i32, neither the 64. It can be from maximum, I guess. There's a quad word, a u quad word, a real 48. Yeah. There's complex 32, a complex 64, a complex 80, a complex 128, and a bar string. Then there's a padding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And if you see there, start from 8000, the thing that he was talking about before, from 80000. Leaving this is reference from symbols. Alright. What else is here? What else is here? You tell me. All these are the... Oh yeah, the types, definition, and all this stuff. Okay. Cool. Classes, structures, unions, procedures, member... Okay. Good. Reference a field, attribute bit field. This bit field has the following format. No access protection, private, protected, public. Oh, okay, so it's referring to the access protection. There's a private, protected, public. The properties for methods: a vanilla method, a virtual method, a static friend, virtual method, pure virtual method, pure introducing virtual method, reserved. Leaf indices, reference from symbols. Okay. This for const volatile unaligned properties for any particular type. Okay, so this is the index to the modified type. So it's gonna get us to the type directly. I mean, if it's a const u32, we're gonna get to the u32 or something, you know, or even type. Yeah, I guess. we have the index to the object pointed to. And the pointer type okay. So yeah, I mean, since we can have like and we can have based on register, isn't it? Where's the register one? Well, yeah, because the address of the symbol can be a register, so it can be a pointer to that register, you know. And this is okay, so this is a pretty much detailed thing of pointers. Okay. I don't know what pointer mode does. It was not here. It has an attribute and the type. And I don't know, I mean 5-bit fields, but 40 non-specifying mode of pointer. Oh, okay. Mode of pointer mode. It's not the same. Oh. I think it's not the same, but the thing I don't understand is this this format of :5. Does that mean the offset or the bit starting bit or what? This is the value for it, but this is, I mean, we know that the attribute is going to be a 2-byte. The type is a 2-byte. The variant is going to be variable. So if the attribute is 5-bit fields, and we know that is inside these 2-byte, then the other bits, they're not going to be used at all, I guess. And the type itself is not here, I guess. Or where is the type? Where is the type? No, this is not. Okay. We have another, and this, I guess this is also in there, the class and the format, but they are not defined there, so I mean the format the format that data is organized is a little bit janky, because, and then there's another one, and man, this is, the pointer is super, look at this. Okay. Oh my god, with pointer things. Yeah. Super crazy. Look at this. I mean, probably this is not the same. We have to read a little bit more carefully about what's this. But yeah. For now, I think it's it's it. We will continue on the next stream looking at the symbol table format and the type table format, which is getting into something, you know, it's getting into something that we can parse and see. Okay, so I would say that please, if you have any questions about what we did today, you can ask me on Twitter, Twitch, or YouTube, and I'll be there to answer. For now, I think that will be all. And yep, I think I will see you all on the next stream.